Hi, I'm Sandy Murphy. I work for Sparta. TISLabs is an ancient email address. I'd like to express the opinion that DHS S&T has been funding a lot of the work in securing the routing infrastructure. You heard Bill Woodward mention it yesterday, and that's the source for my funding. And you've heard a whole lot about the certificate structure for protecting the resources, the IP addresses, and ASN numbers. They've been here, they've been at RIPE, they've been at APNIC and Apricot and everywhere else. There was the Steve Kent, Jeff Houston, Randy Bush Road Show early last year and again last fall. A reminder, this is how addresses are allocated. You're all familiar with this. It goes from IANA to the RIRs and down from there in sub-allocations and assignments. The resource PKI just captures and secures that delegation. At every point that there's a delegation, there's a certificate that goes with it. And then down at the bottom, anyone who holds a certificate for a prefix can sign something that says what ASs are allowed to announce that prefix. Okay, 3 slides, 30 seconds, right? So I'm here to talk to you about the IETF SIDR working group, which was chartered to work on the architecture and the structure for the resource certificates and the secure route origination object, which is called a Route Origination Authority, ROA, pronounced ROA. So if you hear people talking about ROAs, it's not a new animal. There is a resource certificate internet draft that's gone through about 3 versions now. We'll be discussing it at the next IETF. The ROA will be a draft by the next IETF, and we'll have a draft describing the architecture. There have been, as I said, lots and lots of presentations about this, but no one has actually documented it. Okay, some of the discussions we've been having in the SIDR working group concern signing the ROAs. Each of the certificates that I talked about in the resource PKI is a certificate of authority certificate. Common wisdom is you're only supposed to sign certificates with a certificate authority certificate. So what do you use to sign the ROA? The idea is to sign a non-CA certificate, an end entity certificate that will itself be used to sign the ROA. So for every prefix that you want to announce, you generate one of these entity certificates. That makes it possible to revoke the ROA by revoking the certificate that signed it. It also means that if you have a whole bunch of prefixes that you want to announce, you generate one of these for every one of the prefixes, so you have control over what gets announced to what without combining and do fate sharing in a whole bunch of prefixes in one certificate. So the idea, the discussions going on right now for what a ROA would contain is that it's actually going to end up being very simple. A ROA will authorize one ISP to announce your prefix, and it'll be by mask. So if you're multi-homed, you sign 2 ROAs. That way, if you're multi-homed and you lose one of your agreements, you don't have to revoke the other authority. You can just create a new ROA for the prefix for anyone else that you're going to be going to. There's a question right now that if an ISP itself owns more than one AS number, whether we want to do that by listing the ASs in a ROA or by creating a list of ROAs. And then the prefixes, there's a discussion as to whether or not the prefixes would actually be represented in the ROA itself. Because the end entity certificate itself says what the prefix is, and there's one end entity certificate for each ROA, the ROA doesn't actually need to contain the prefix, but it might be useful for it to contain the prefix for purposes of looking at it and knowing what it was about. At the last IETF meeting, we discussed the authorization model, who authorizes the advertisement of a prefix. The RIPE model, if you put a route object in the RIPE database, you have to have the authority of both the prefix holder and the AS holder. So if you say that AS100 is allowed to advertise your prefix, AS100 has to say, yep, that's right. The working group decided that that wasn't necessary in the case of the certificates that were, the ROAs that we are defining. Then there was a kind of back and forth discussion about route validity. If there is a route that is advertised, must the ROA exactly match that prefix, or can it be a superset of the prefix? And the case for making it exact match is that it would prevent some accidental leakage problems. The case for making it a covering match is that it becomes, you start having to have a large number of ROAs if you have to have one per sub-prefix. I'd also like to tell you about some work we're doing to try to create a roadmap for what it would take to secure the routing infrastructure. This is an overall picture of what we're doing, trying to define all the activities that would have to take place in the terms of research, near-term and rather long-term research, and current techniques that could be used but aren't deployed or in use too much. So there's a deployment track and a research track, and this is a small overview of what the roadmap document likes. If you want to see the roadmap itself, it's at that URL. We're looking for input as to whether we're identifying all of the relevant activities that would have to take place in order to get this done. The idea is that if you know what needs to get done, you can go help make it happen. So here I am asking you again, please participate in the SIDR working group. The discussions that are taking place, deciding what the content will be and what the hierarchy will look like, is being made with the intent of facilitating operation and deployment of this without a huge number of operators in the working group. So there's the working group charter. You can look at the mailing list archive. There's the mailing list, join up, express an opinion. Let us know if any of what is being suggested is not going to work in your current operational practices. Done. Questions?
Yeah, you have time for questions, and I see Bill Woodcock coming to the mic.
Hi, Sandy. So,
Hi.
Operators have traditionally been pretty averse to adding external dependencies, particularly ones which are, by their nature, single points of failure. Mm-hmm. And this needn't, by its nature, be a single point of failure. So I'm curious whether you could just briefly address the pros and cons of single centralized authority for the signatures versus web of trust.
Okay. So this is what the address delegation looks like. It all comes down in a rooted hierarchy. The resource PKI, I've represented it here as if it were exactly that same rooted hierarchy, but it is the intention of the SIDR working group to make it possible to represent other sorts of trust mechanisms, trust models. Okay, so if you don't trust IANA and you can get someone else to sign a certificate saying that you hold a prefix and other people will trust that other signer, it is supposed to all work. That's the intent.
Michael Richardson, I'll just add to that as a security geek. With 3 to 10 pieces at the top, you should be able to, completely believe IANA is rogue and configure 10 keys, and you could even go down and configure ISP keys. I don't see why that shouldn't matter, and I don't think it even needs any particular magic in the ASN1 X509 group to do it. So I don't see why this shouldn't be successful, provided the software lets you do it. And I think the other thing to remember is this is not necessarily going to run in your BGP engine, but
Right.
rather in your access list creation program, where you have lots of RAM and lots of operator intervention to be able to say, oh, but yeah, I know they're screwed right now, so I'll make an exception.
Yeah. The policy is always a local matter. What you accept, what you do if you don't have a certificate for a prefix is going to be totally up to the operators. There are people who are very strongly motivated or very strongly opinioned that the IANA single-rooted model is not good, and that's why we're working very hard to make sure that it works with other trust models. Randy.
Randy Bush at IIJ, as one of the people actually implementing, while admittedly ignoring the IETF, though some others are, and Jeff and Rob play in the IETF and George. The centralization doesn't exist in the plan, and it doesn't exist in the software that's being built. It's a bogeyman. The fact is, the address structure is hierarchically allocated, as you make very clear, and you're going to have to trust as origin data the IANA for saying to which registry or which legacy they allocated those data. If you don't trust them to say who they gave it to, then it all falls apart. If you don't trust the registry to say, Aaron to say to whom they gave it, you have nothing to base anything on. The current structure for generating access lists, and by the way, I intend to put this stuff in my routers, and the current stuff to generate access lists, in fact, trusts some horrible data that is centralized in a very few locations, and yet we limp along on it because we haven't got a lot of other choices. Operators were pragmatic. What is the actual trust structure we have today? And that is, we trust the registries to say who gave this garbage to, and the recipient, we trust UUNet to say who they gave it to, and that's life in the big city. And yes, the software will allow you to configure whatever trust anchors you want, and are you going to be happy when somebody in Kansas decides to trust Eugene Kashparev? Well, that's your choice. I wouldn't trust him, and there are people in this room I wouldn't trust.
Okay, I'm sorry, you're over your 10 minutes now, so the mic is closed. I can't take that question, and I'm sorry. You're well over your 10 minutes. Thank you.